Hi, so we are back. This is the second video. The first one we talked a little bit about how clouds form. We had just left off on where clouds form. So you should be on the back side of your first page where there's a blue outline, the second blue outlined box, and it should read this. Small airborne particles upon which water vapor condenses will form clouds. You might have two form clouds. Just cross it out and put will form clouds. Want to talk here two vocabulary words you need to understand and how clouds form. One is adiabatic cooling. That's how you pronounce it, like the name Addy, and then abatic. So adiabatic cooling, this is the cooling of gas, where temperature change will allow condensation that makes most clouds. Another word you're going to want to know, there are pictures of this, by the way, on your guided notes. So adiabatic cooling, there are two pictures of that where you can see where the warm air will actually come out as a cool, humid air, and just kind of a little description of what those molecules do when they rise. The other vocab word about how clouds form you're going to want to understand is distillation. This you might have heard of. You may have drank distilled water before, or you may use it in the machines that you have. Distillation is a process used in chemistry a lot as well, and it's just when you are separating out different individual parts. You are distilling. So like for the water, you're taking out certain impurities, you're separating those impurities from the actual water, so you have more pure water when it is distilled. So evaporation and condensation of a mixture to separate out the mixture's individual parts is called distillation. We already talked on the last video how clouds form, but there's a couple more diagrams in here. If we were in class together, we would listen to the cloud song here, and I would have you write down everything you remember, but we will do that when we get back. I want to talk quickly here about residence time. When I think of residence time, I think of like where I live. That's what we call our residence, where we live, where we spend the most time. So the average time that a given particle will stay in a given system is called its residence time. So if you think of like an ocean, a drop of ocean water, or a molecule in the ocean, its residence time is going to be a lot longer because there's a lot more molecules. So if you're a drop in the ocean, drops in the ocean can be there about 3,000 years or longer before they actually evaporate and become part of the water cycle. So residence time is longer. You can fill in the blanks here. Residence time is longer in the ocean because there are more water molecules that need to evaporate. All right, so we have water table and percolation that we're going to talk about here really quick. There's a picture of a water table on your guided notes. You're going to want to know how to label that water table line. This is the line between the water saturated soil and the soil that is not saturated with the water. And then percolation, if you think of something kind of percolating, it's kind of, I think of it like trickling down. Percolation is a process where water will move down towards the soil and towards the water table. So percolation will be moving down towards the water table, or the water will be moving down. And then for ocean water, specifically here we're talking about ocean water, and 95% of the ocean is water. And the other 5% is a mixture. There's about 2.7% of the ocean that we found to have sodium chloride or table salt. And then 0.8% of the ocean will have other salts like magnesium chloride, which you may have heard of as Epsom salts. You can find those at like Bath and Body Works and places like that. They are used for skin care and other things. And then salt will accumulate in lakes and oceans if the only way for water to escape is through evaporation. So that means that a lake can have salt water in it if its method of evaporation, if evaporation is its only means of getting rid of that water. So yeah, you can have a mixture of salt and fresh water. And then what do oceans tell us about the age of the earth? And this is a debate, old earth, young earth. We've talked about it in class. Well, the Bible has stood the test of time. And this is one more piece of evidence that points us to how God has created the world just right for us to live in. The salt level of the ocean supports a young earth. If the earth were millions of years old, the ocean would be much saltier. And so about 6,000 years versus like millions and billions of years, like some textbooks would tell